Hello guys. So today I'm starting with the binary search, just little bit more in details. So first of all, why we use binary search? So basically, so let's say if you have some 10 million elements, so if you do some kind of linearly search, so let's say I'll just type here. So n is basically 1 million. So basically it will take a time around 52 seconds based on your machine configuration. But if you do a binary search, it will take a log n time. And the time complexity will be reduced to around 1.5 second or something, or 1.6 something. Yeah, so it's very efficient. So I'll just go into three kind of problems. I'll just write down here what all three kind of problems I'll. So first I'll tell. So basically this binary search is only for a sorted kind of elements only, and it can have a duplicate elements also. That kind of problem will also look into it. Then second will be, yeah, so basically if you have around 1 2 2 3 4, so we have to tell the first index, that is 2, right? And the third problem will be, so if you have a number like 1 4 5 5 6, so we have to tell this index, the second last index, right? So basically this is the framework which we already have. So here you see I have just dotted out certain lines. So while you see there is some dot, so inside while loop some things needs to be filled out. The problem will be if we find the target, we'll just return that index, otherwise we'll return -1. So the first problem will start with just a simple base problem, finding a target. So I already have written this. I'll just copy paste here. Yeah, problem. So here you see I have defined left is equal to 0 and the right is equal to the last element, nums dot length -1. Basically, it basically means left comma right, both included. So so why we did, I'll just tell. So we have a loop left less than equal to right. So the terminating condition will only happen when left is equal to right plus 1, right? So let's say if we have few elements 4, 5, 6, 7. So let's say we are at the last index. So left and right both are same. So if we do left less than right, so we'll miss this case 7 comma 7, right? And that's why, so basically if we do left less than right, the terminating condition will change to left is equal to right, right? And this is the left is equal to right, and if we do like this, we'll miss this kind of case. So that's why we are doing like this. So we have to count this case also. That's why we have done like this. And then if we come inside while loop, we'll take a mid element. So here I have done left plus right minus left by 2. It is almost same as some people write as same as left plus right by 2. But the problem is if you do like this, you might get integer overflow exception. So it's better to do this way. And then we see if the element matches with the target, we'll just return that index. If it is less than target, we'll just move the left. So here the idea is you should see that where this symbol, the open bracket is pointing to. So it is pointing to target, so it must the number must present in the right half. So you have to move the left. And here it is pointing towards left side, so number must present in the left half. So just move the right to mid -1. So why we are doing this? So basically we have already searched the mid element. So if you have element like 1 2 3 4 5, we have already searched this for the first time here, and we couldn't find, and the target is, let's say, 2. So we have to move to left half. Otherwise, if your target is 4, we have to move to right half, right? Yeah. And the earlier, and if we don't find any element, we'll just return -1. Yeah, so earlier we said that we can write here left less than right. So if we do this, the terminating condition will change to left is equal to right. And in that case, you have to do something at the end because as we said, you are not considering last case. You are missing because your if when your last index left and right will match, it will terminate, it won't go inside. So you have to do something here. If left if num left is equal to target, just return left or else minus 1. Yeah, this kind of thing you have to do if you take left less than right. Otherwise, if you keep it left less than equal to right, just have just while loop will take care of all that. Okay, this is the first base problem. Now we'll go to the second problem. I have already done this before, so I'll just for making short video, I'll just copy paste here. So here we are, what we are doing, we are just finding the leftmost target in sorted number. So if you have some number 1, 2, 2, 4, so we have to tell the first index, right? So here I have taken left is equal to 0, right is equal to nums dot length. So earlier we were doing here we are taking the length of the all the elements. We are not doing minus 1 here like we did in earlier case. I'll tell you why. Okay, and then the while loop we have left less than right. So the terminating condition is when left will become a right. Now we are finding a mid element, and here is a one interesting thing. If your number matches with the target, you don't need to return anything. You just bring your right pointer to that element so that you can keep shrinking your left half to get that leftmost element. And if number is less than target, then you have to move left. Otherwise, if number is greater than target, then the right will become mid here. And at the last, we are returning left. Now you must be thinking where I am returning minus 1. What if element is not present? Okay. Yeah, so let's consider this case, why I am returning left like this. So I'll tell you, I have to add two more lines after while loop. So I'll just explain here. So let's say if we have elements like this, 1, 3, 4, 5, 6. So now say the target is 0. So left will be 0 based on our algorithm. Now say left is equal to 1. Target is equal to 1. Then left, sorry, the sorry, let's say the target is equal to 3, then left will be 1. Because, and what does that 1 says? That there is only one element smaller than 3. And what if element is 7? Then left will become 5. What it says? That there are 5 elements less than 7, right? So what if it is yeah, so you can see the left is varying between 0 to that number, the number of elements. So when we reach the end of the element, the greater than number of elements index based on index, then we can return minus 1 otherwise. So here we can do some changes. So if left is equal to nums dot length, just return minus 1, else return nums left equal to target left or minus 1. Yeah, so this is a very simple problem. So now, yeah, hope you understood why we are doing this. So now I'll just move to the third kind of problem. Yeah, but yeah, one thing I forgot. So we can also do this second problem. We can also do like a previous way. So we can put right nums dot length 1 minus 1, We can do this. We have to make some changes here. If mid is equal to target, then we have to make right mid -1. This is fine. And then if mid is greater than target, we have to make -1. And here we have to make some changes. If so, your terminating condition will also change. It will be right +1. It will go out of index. So we have to see this thing. If num greater left greater than is equal to num dot length, then return -1. Yeah, so these kind of changes we need to do to make it close bracket this thing the same as base problem. Yeah. Now we'll come to the third kind of problem. Yeah, so we have this. Sorry, I'll just copy paste here the third problem. Yeah, so we have to do a rightmost target, find the rightmost target in sorted number. So let's say 1, 2, 3, 4, 4. So we have to find the fourth index, the last fourth. Yeah, so here also we have taken left 0, right nums dot length. Same as previous one, while left is less than right, and the terminating condition will be until when left becomes right. So we have a mid element as same way we were doing here. We don't here we can also write left plus right by 2. We don't need to worry about integer overflow exception because we are doing left less than right. Now if the number is matching with the target, we are not returning anything. Instead of that, we are just moving left to the mid +1. So earlier what we were doing, if we had to go to find the leftmost, then we were making right is equal to mid, right? And the second, if number is less than target, we are moving left to mid +1. Otherwise, right is equal to mid. And then we are returning left -1. It is because if by chance number has matched with the target, then left has increased by 1, right? So we have to return the left -1. Now you must be thinking, where are we returning -1 if the element is not present at all? So that also I'll just tell you. I'll just need to write 2, 3 lines for that. So let's say our example is 1, 4, 5, 6. So in this case also, so if your target is 5, then your left will be 6 because of this. So you have to return some left -1. And if number is not present at all, then you can say left is equal to 0. In the earlier example, second problem, we were saying if left is greater than is equal to nums dot length. Similarly, here we can say if left is equal to 0, just return -1. Otherwise, just return nums left -1 is equal to target left -1. Otherwise, -1. Yeah. So here left, and you don't get confused why I'm not writing a right here, because you can use right also, as both are same only. So now we can do this based according to the base problem. So here you can write -1. Now here you can do nums left less than equal to right, and terminating condition will become left plus right +1. And here also, here everything is fine, seems. Left is equal to mid +1, mid +1. Yeah, right here you can choose as mid -1. But some of the condition here will change, this condition. So we have to check the out of index. So if right basically is out of bound, so basically if right is less than 0, if it is going out, I'll just return -1. Otherwise, if nums right is equal to target, just return right, return -1. That's it, guys. Thank you.